Hello and welcome to another video. In this one, we're going to be talking about a cool project that I've been working on almost a year at this point, although for about a year of it, I wasn't working on it. So anyway, the project is I have made a custom controller which I can control programmatically using Python or Bash or whatever I want to, that allows me to send inputs to a, vanilla Nintendo Switch, which I think is really cool. But anyway, let me show you how you could, set this up yourself and some of the software and tools and tricks that I learned along the way. Now, note I am not, I'm not very much of an electronics person, so if any of the stuff that I say is wrong, please correct me in the comments. I learned almost all of this while working on this project, so it's possible that, I have some of my terminology wrong or like I'm doing things poorly or whatever. But anyway, let's jump into it. So this project is relatively cheap. I think the total, well, I've spent a lot more money on this than you will need to. But I think the total for all of the parts, if you include all the cables, is around 20 bucks to set this up, which is, significantly cheaper than buying an actual controller, which is great as well. But yeah, before we get started, I want to show you some of the stuff that this can do. But the opportunities for this project are kind of limitless if you include, computer vision stuff, because you could hook your Switch up to a capture card and then, have a program scrape the screen and then respond based on that. I haven't done any of that yet, but I'm excited to try it out eventually. But yeah, let me show you some of the stuff that I've done so far. So this is from a stream that I did a few days ago, where we were automatically resetting to get shiny Pokemon from raid dens. Now this is an earlier version of the code here, so, and you can't really see it on stream anyway, but this is a prompt over here, and these are the inputs that it was sending. And you'll see that we run this here. I run a bit of code, and this switch down here is playing by itself. So I am not pressing any controls on the keyboard. The microcontroller is controlling the switch entirely. And, pretty soon into this, you'll see that I was able to obtain a shiny Pokemon just from having, an automated thing go through and and click the game for me. So that was kind of cool. Another thing that I did with this is I made it really easy to release Pokemon. Again, this is kind of small, so maybe you can't see it, but there's a box down here which will contain a bunch of Pokemon, and it's basically just going to select them one by one and release them. So this is a very, very tedious task to do manually, but really, really easy for a computer to do this. So you can see it's selecting them all right now. And basically, any of those sorts of ideas are possible with this. Let's jump into the parts for this. There are two main parts to this. One is the Pro Micro, or some compatible, Arduino-like device. I picked the Pro Micro because I had a few laying around. I actually had them laying around from a keyboard project. So this is the Pro Micro here. They're particularly popular in making custom mechanical keyboards, and I actually had one myself from Kibio, and that was the one that I used. But this is, $8 for one of these things. Now, the ones from Kibio don't come with the pins pre-soldered, so if you want to avoid soldering, which this was actually one of my first soldering projects as well, and I'm garbage at soldering. If you want to avoid soldering, you can get pre-pinned ones, which you might want for this project. But I soldered these pins, and they weren't too bad. My soldering is not great, but it worked out fine. I'll actually show you on a bigger screen at some point once we get past this part. The other part that you'll need, and we won't need to do any soldering for this, is a FTDI chip, a USB to serial converter, and that's this guy right here. What this does is it takes a USB input and converts into something that you can connect to a microcontroller and have it, respond based on stuff. Basically, I'm using this so that my computer can control this chip while this chip controls the switch. And beyond that, you'll need some wires. I have a few wires here. This is mostly to hook the two things together. And you'll also need USB cables to hook all the other stuff together. Some optional stuff that I find nice to make this project a little bit easier to work with. I guess we can go to this view now. The white balance is messed up. So just to show you the parts again, this is the Pro Micro, and I have soldered pins onto it so that it's easy to put into a breadboard. And this is the, FTDI USB to serial chip that I'm using. One thing to note when you're buying parts is to make sure that the voltages match. So this particular Pro Micro is a 5 volts device, and this FTDI can be either. It has a toggle switch, so I have it in the 5 volt mode right now. So it's useful to make sure you match voltages there. But yeah, some other optional things that might make this project easier is a breadboard, and this can be useful to put your things down so they don't move and you don't have like loose wires. And I find it's a lot easier to organize my thoughts on a breadboard like so. I have also set up a previous breadboard, but I'm we'll get to this part later. This is kind of the optional other stuff. So I have a reset switch, which is going to make part programming it a lot easier. I also have a buzzer that I can optionally trigger when it's done, and I'll show you this assembled later. But we're gonna assume we're going from scratch, and so we're just gonna have a blank breadboard today. Right. So the first thing that we're gonna want to do is take our microchip and put it onto our breadboard. And this can be pretty tricky because the pins don't like to push into the surface all that well. So I found a little trick for this, and I know this ruins the breadboard. So if you're yeah, if you're a true electronics nerd, shield your eyes. But what I've been doing to make it easier, because pushing this in is very tricky. What I do to make this easier is I take a push pin. This is just like a pin that you can hang up posters or whatever with, and I find it easy to take the pin and push it into the individual slots of the breadboard. And so push it most of the way in. If you push it all the way in, it's really hard to get out. So I find pushing it most of the way in easy. And this kind of spreads. There's little pins in there, and it kind of spreads them apart, breaking them open so it's easier to insert pins into there. Just a little trick. Ruins the breadboard, but makes it easier for me to insert this. I've actually already. Why are you hard to put in? I've already done that to this breadboard, so it is not going in all that easily. Why not? Oh, come on. Oh, do I have to show it on the other one? There we go. Yeah, so once you've got that, you can seat your microchip into the breadboard. So I've pushed it all the way in, and I've ruined the 22 pins that are necessary for this one here. You can actually use other Arduinos. I have not tried any of the other one, but this one is convenient because it has a single processor, and that processor has a separate serial from the serial that controls it. So I was playing with an Arduino Uno and was having trouble with it because the serial is shared by the USB driver. So just a thing to look out for. I know this particular combination that I've listed in my README works. Oh, by the way, I will have that GitHub URL in the description, so you can look at that as well. Okay, so once we have this seated in here, we want to connect the USB to serial converter to this board. And there are 4 wires that we'll need here. Note that I'm using male to female wires here. And this is, I'm going to be sticking the male wires into the breadboard, and I'm going to be taking the female wires onto the pins that we see here. Now note there are 6 pins here. We only care about 4 of them. And if you look on your device, I don't know if we can get the camera to focus here. Nope. But it'll label the wires here, and I've actually put a helpful diagram in here so that you can see which wires match with which wires. So we are caring about the 5 volt, the ground, the TX, and the RX, and we're going to be matching that TX, RX, ground, and VCC. So this is, I think, voltage input. So 5 volts to VCC, ground to ground, and TX, RX will actually cross over. This is important, otherwise you won't be able to connect. And this buzzer, this is one of the optional components that I showed earlier. So I'm going to hook this up. I'm going to start by doing TX and RX since they are the easiest. Okay. And I know wire nerds usually have their particular color schemes. I'm not going to do any special color schemes here because I don't have any memorized, but I have put TX on orange, so we need to make sure that RX is orange over here. And I'm just going to slot these directly into my breadboard here. Come on. I haven't ruined these holes yet, so it's kind of hard to stick in there. Okay, so those are the first ones. Oh, let me put it back on the screen so you can see it. Yeah, so I've slotted in, RX is the second pin here, and so I've slotted in orange there. And over here, RX is the second pin in, and that one is yellow. And TX is the third pin in. So that's kind of the first step here. Now, for whatever reason, when I first assembled this project, this was all I needed. And this worked fine on one of my computers, but not on the other one. And I don't know the reason for that, so if you know the reason for that, put it in the comments. I would appreciate that. Okay, so the rest that we need are 5 volt and ground. I'm going to put ground on brown and 5 volt on red. And so I've just hooked those in based on this. And then over here, there's a lot of choices for grounds. One common thing to do on a breadboard is to patch ground to minus and patch voltage to plus, and so then it'd be very easy to just slot this in on plus and minus. I have not set up jumper wires to do that, so I'm going to just pin them directly to the board in this case. So we are going to put voltage to VCC, so red to this one, and brown to ground. Cool. And that is all the wiring that you will need to do for this. Now note, this is a little bit unwieldy. What I actually want to do later, and I don't have the parts to do this yet, is to set this onto the breadboard and wire this directly into the breadboard, and then I can use jumpers directly on the breadboard without having to have these wild cables here, and just have these essentially, probably glued down, because honestly, I don't think I'm gonna take this apart at some point, and so then I would be able to just connect to this directly. But I haven't done that yet, so I have these wild wires. And that's all you really need to do the assembly part of this. Let's talk about the programming part of this next. And the programming part is pretty tricky. And this is actually one of the reasons why I have put a reset switch on mine. I find that programming the device to be a little bit annoying. So let's go back to our README and go through our installation parts here. So I'm working on Linux here, and you'll want to run this first if you're on a Debian or Ubuntu image. I don't know the proper things to install for others, but you'll need the GCC, the AVR flavor of GCC, the AVR flavor of libc, and you'll need DFU programming. Actually, I think this is optional, and maybe I should have updated this. I think I actually have AVR dude instead of DFU programmer, but either one will work. The DFU programmer will be a different set of command line. Once you have those installed, you'll clone this repository. There's also lots of forks of this, so if you're looking around for other ways that other people have done this, you can look through other forks. I mostly took an existing one and modified it a lot for my use cases. So once you have the repository clone, which I have it cloned here, you will run make. You have to match the processor ID with whatever processor you have. This is the processor for the Pro Micro, so if we copy that here and paste, you'll see that it has run make. Yours will have potentially more output than this. Once you have made this, the next step that we're going to do is flash it onto the Pro Micro chip here. And so what you'll need to do for that is connect it up to your computer. Another note, if you're working in a virtual machine like I am, you'll want to make sure that you have assigned your particular USB devices here. This devices menu up here, you can't really see it because it's off screen. Devices, USB, this is for temporary setting them up. And you can go to USB settings to make them permanently attach to your device. And in my case, I have two devices here. This is the FTDI USB to serial, and this is the Pro Micro chip. It shows up as a Leonardo because they are the same chipset or whatever, so it emulates this one. And sending this up here will make it automatically attached to your virtual machine. If you're working directly on the host, you won't have these problems. But okay, next I'm going to take the USB cable for the Pro Micro, so that is the microchip itself, and I'm going to hook this into my computer. So we plug that in here and plug it in here. The first time you start this up, it should have a default program on it. Oh, why didn't that work? Why do you not have colored lights? Uh-oh. Not good. Let me try a different USB port. Have I broken my microchip while recording this? Yeah, that's not good. Well, I might have to record this at another date. Well, I'm gonna pause the recording here and figure out what's wrong here. All right, so I figured out what was wrong. I had my I had my ground and 5 volts crossed, which I think made it short, and so it wasn't going to register as a USB device. But anyway, now that that's fixed, we're gonna plug it into the computer. So I'm gonna take USB cable and plug it into my computer and plug it in here. Now, if this is the first time you've plugged it in, it should have a default blinking program on it already. However, my case, I have already programmed this, so it's just gonna have a solid light. But if you have the blinking program, it'll blink on and off every second. And that's just kind of the default Arduino program that ships on these chips. You'll note that both of these devices are actually lit up right now. And that is because we have wired power through to this other thing here. And now we get to the hard part, which is programming this device. We go back over to this scene. We actually need to time this very, very quickly. We need to reset the device, and the way we reset the device is by shorting, reset to ground twice in quick succession, and that will cause it to enter the DFU programming mode. And that's actually the reason why I have a little button on this over here, is that makes resetting easy. So to do that, what we're going to do is we're going to copy this command, and I usually find it useful to do sudo -- validate, just so we get our bad password typed in out of the way, so we don't have to race to type our password. And then you need to short those. So I have a button on my board, but what I was using before is a headphone cable to just tap the 2 pins and bridge them. It's gonna be really, I don't know if we're gonna be able to see it. But basically what I'm gonna do is get in there and tap the 2 pins while it is hooked up, and that should turn it into programming mode. And you'll hear Windows go boop as it disconnects. And so just tap those twice and quickly paste this command, and it should do, you should have progress bars, and that's it writing it. Once it's done, it will disconnect, and it will reconnect to your computer as the Switch controller. And in my case, this happens to open up Steam, because Steam's like, oh, you connected a game controller, you must be playing games. Cool. So once that's all done, we can actually hook this up to our Switch and start demoing this. So let me start up my Nintendo Switch. So I have, that's the black screen down there. I'm actually using a normal Pro controller right now to show that. I'm actually playing Pokemon at the moment. And in order to start using this, the way this works is it registers as a Pokken controller, which is a Wii U controller. And to get started with this, you have to go into the home menu and go to controllers. I recommend being in a game before you start this, just because that's how it does its little boot sequence. And you go to change grip/order, and it'll ask you to disconnect connections. And then this is the point where you can plug the controller, which was currently plugged into a computer. You can take this and plug it into a USB port on your Switch. I have it in the dock right now, but you could use a USB-C cable instead and plug it directly into the Switch. And when you plug it in here, the controller is going to do a boot up sequence. Oh shoot, these buttons are pressed. Dang it. Hold on, I'll have to do this again. It's supposed to disconnect the other controller, otherwise none of this works. But it's because I pressed L and R while I was setting it down. So I'm going to disconnect it again, go back to the home menu just to show you this twice. Go to controllers, change order/grip, deactivate local connections. That should disconnect this controller. Don't press any buttons on it or it will reconnect. I'm going to set that down gently. Plug in your USB cable to your microcontroller, and then it should boot up. It'll press buttons and go into the game automatically for you. Just like that. Cool. So once that is set up, we are going to take the USB to serial device and we're going to hook that into our computer. So I have another USB cable for that here. So I'm going to plug in the micro USB or mini USB on this side. Yeah, you have to juggle USB adapters for this, which is kind of annoying. Plug that into my computer, and this is actually associated that device with my virtual machines. So we should see here under devices USB that we have this FTDI USB UART device, and that is the serial device that controls this. Now, from that, we have created a bridge from my computer into this device here, this device into the controller, and from the controller into the switch. And so now with that, we can use code to control the switch. I've included a few sample scripts inside this, this repository here. Oh, my keyboard's all off to the side, so I'm having a really hard time typing here. But I've included a few Python scripts here. Not all of these are actually checked in. But the simplest one is this press script, and I'll show you how that works. So basically what this is going to do is it's connecting to a particular serial device. I've set up some parameters to say like what key is it going to press, what duration is it going to press. It connects to the serial device, and then for however many counts, by default it's 1, it will push a particular button. And it does that by writing a command to the serial and then writing a 0 to the serial. Note this is a ASCII 0, not a null byte. And those commands are listed here in the README. I have a bunch of different commands here. There's a verbose mode if you want the controller to tell you that it receives something. There's this special command to trigger the buzzer if you have the buzzer enabled. And all the other buttons that you would want to press on your switch, as well as directions. So if you wanted to move around, you can do that. So I'm just going to run this press script to show you how it works. Python 3-m press A. So we're going to press the A button, and you'll see that it talks to the lady there. And if we press B, it'll exit out of this dialogue. She says, "Don't be so haughty. Don't act so haughty." I don't know what her deal is. But yeah, I'm able to control the switch using a little bit of Python code. And you can imagine, writing a little bit of bash that calls this script, and you can do all sorts of cool stuff with this. Now, some of those things that I showed you earlier in the video are captured in some of these other scripts. So, for instance, what I'm actually doing right now here is reviving fossils. So, if we look at this revive fossils.py script, I've set up a little bit of logic here. Now, note this isn't actually scraping the screen and reacting to it. I've just manually timed this out and have sleeps between button presses here repeatedly, and manually figured out exactly how much time I need to wait in order for them to work perfectly. So if we want to, for instance, python-m revive fossils, part 1 top, part 2 top count, I don't know, let's do 2 fossils, for instance. You'll see that it starts reviving fossils. So it runs, a bit of code that happens to know the exact amount of wait time to, match up with the dialogues and press the buttons there, and continually get this Pokemon here. And I'm trying to get this particular Pokemon shiny, and so I need to do this somewhere around 4,000 times on average to get a shiny Pokemon. But anyway, the possibilities are kind of endless with this. You can automate any sort of tedious task that you want to do this. I kind of want to write an AI that plays the game, or maybe like do a Twitch plays Switch where, this is just code. I could hook this up to a Twitch bot that, controls the Switch directly or something like that. But there's all sorts of different options here. Oh yeah, and another thing that this does is after it's done, it opens up the Pokedex so you can see whether or not you got it shiny. In this case, I didn't, so yeah, it's all cool. And then I can run, python-m reset, and this will reset and soft reset the Switch, and you can, play the game essentially like that. But anyway, I think this project is really cool. I've been having a lot of fun working on this, and I'm not a hardware person, so this has been way out of my depth. I've learned a ton of stuff while working on this. But yeah, looking forward to what else I build with this. Hopefully this was interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.